Hello everyone. In this video we're going to be solving a nice exponential functional equation. So we have f of e to the power x plus 1 divided by e to the power x minus 1 equals x, and we're going to be finding an expression for f of x. So for this purpose we are going to use substitution. And since you are trying to get an expression for f of something like some variable, doesn't have to be f of x. Some people are confused when I use the same x for different purposes. It doesn't matter. You can use a t or a z, anything you like. You can even use, I don't know, any letter. Okay, psi maybe. So let's go ahead and set this whole thing equal to t. Okay, we're going by t today. So now that means e to the power x plus 1 divided by e to the power x minus 1 equals t. All right, great. So from here, my goal is going to be to solve for x in terms of t. But solving for x directly is kind of hard, so I'm going to try to solve for e to the power x first. If you want, you can also go ahead and set e to the power x equal to something like z, and then write this as z plus 1 over z minus 1 equals t, and then solve for z in terms of t, and then back substitute, but I don't think that's necessary. It's too much work. So let's go ahead and do this. Cross multiply. So multiply these. And now we're going to get e to the power x plus 1 equals t times e to the power x minus 1. T time. It's t time. Okay, now let's go ahead and distribute e to the power x plus 1, t times e to the power x minus t. Since my goal is to solve for e to the power x first, let's go ahead and put everything on the same side that has e to the x. And I want to stay positive because that's what I like. So let's go ahead and throw the negative t in here and put the e to the x on the other side. So it looks like this. 1 plus t equals t e to the x minus e to the x, and then 1 plus t equals e to the x out, t minus 1. Notice that you need t to get t e to the x, so we're basically factoring out e to the x. Make sense? And then divide both sides by t minus 1, and you got e to the x by itself. But let's write it with e to the x on the left hand side and a little nicer, you know, our polynomial in standard form. Otherwise the teacher is going to be mad at us, right? We always have to write in standard form. So this is what we got, e to the x. So but we do need x, so how do you get x from here? Easy, by doing ln or natural log on both sides, because if you do natural log of e to the x, then you get x by definition, right? Okay, that's how e to the x is defined, or that's how ln or natural log is defined. So natural log is basically used to find the exponent. When the exponent is unknown, we use natural log to find it, assuming everything else is known. So we're going to be doing ln or natural log of e to the x is the same as natural log of t plus 1 over t minus 1. But notice that ln something is a function, so like f of z equals ln z is a function. Therefore, if a equals b, then ln a equals ln b, which is something that's needed for well-definedness of functions. Okay, anyways, the opposite is not always true because that just indicates it's 1-to-1, which may not be. Sometimes ln is 1-to-1, but not all functions are. Y equals x squared is not 1-to-1. Anyways, that's another story. Let's go ahead and simplify this. Take the x down, and ln e is 1, so this is x equals ln t plus 1 over t minus 1. Great. Obviously, there are some limitations, like t cannot be 1, t plus 1 over t minus 1 cannot be negative. We can talk about those next. Let's go ahead and finalize our thing in terms of x, and then we're going to talk about the domain. Okay? And let's see. So what do I have so far? I have f of this thing, which is t, by the way. So I have f of t equals ln t plus 1 over t minus 1. Great, so it's pretty much everything. Remember, t comes from e to the x plus 1 over e to the x minus 1. And this gives us x equals this, and we plugged it in here because we had x on the right hand side. Make sense? Okay, great. So we got our function in terms of t, but if you don't like t, you can just go ahead and replace t with x again. And again, this x is not the same x as before. It's just a dummy variable. So don't take it too seriously. And just go with the flow, or flow with the go, however you want to do it. And this is going to be our function as expressed as f of x. So let's go ahead and talk about the domain of this function. Maybe you can also talk about an alternative method, like is there another way to solve this problem? We can also quickly discuss that, but please comment down below if you have any other ideas. And you guys are great with ideas all the time. I learn a lot from your comments. I don't know if you learn anything from these videos, but hopefully you do. Anyways, so this is our f of x, and that's pretty much the answer. But what about the domain of this function? Okay, great. So now, in the first scenario, by the way, could x be anything, right? You can kind of think about it like x couldn't be 0. Why? Because e to the power 0 is 1, and 1 minus 1 is 0, so you would have something undefined. So 0 is not allowed. Okay, so let's go ahead and take a look at this function here. X plus 1 over x minus 1 needs to be greater than 0. That's the only restriction we have, and you can easily solve for it by making a table of values like this, 3 rows, x plus 1 here, x minus 1 here. The roots are -1 and +1. This is the -1, this is the +1. Where it changes sign, it's going to be positive if x is greater than -1. X plus 1 is going to be positive, otherwise it's negative. X minus 1 is positive if x is greater than 1, and otherwise it's negative. Their quotient, obviously we're not looking at equal sign, so their quotient, which is this, is going to be positive here, negative here, and positive here. Since we want it to be positive, our x values cannot be between -1 and 1. Obviously that includes 0, so 0 is not in the domain, but pretty much everything else is in the domain. Notice that x can be negative as long as it's less than, not less than or equal to, but less than -1. In the real world, ln 0 is not well defined. And this brings us to the end of this video. Thank you for watching. Oh, by the way, before I finish the video, I forgot to explore a little bit further for an alternative solution. Let's go ahead and take a quick look. No graph today. I'm sorry about that, but I couldn't find a nice graph for this, and Desmos can't graph anything like this. I tried to graph it, and it's like, I don't understand, there are too many variables. Anyways, just started crying. So this is the original problem. Is there a way to find f of x in an easy way from here? Like, for example, can you divide everything by e to the x? Maybe 1 plus 1 over e to the x over 1 minus 1 over e to the x, and then calling it something. Well, I don't think it's going to amount to anything significant, but if you do know any other method, please let me know if there's any other way to do it. And this really brings us to the end of this video. Thank you for watching. I hope you enjoyed. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time. I think it's going to be who knows when, right? Until then, be safe, take care, and bye-bye.